Hello, my name is Stephen Key, and this is the Shared Data Architecture Keyword and Context System by Stephen Key and Chad Marshall. First, let's talk about the allocation of work. So what I did was I coded the components iLineSet, line storage, line, word, alphabetizer, and circular shifter, while also making the designs for the system's diagrams. And Chad coded the components input, output, button event handler, and master control, while also connecting all of the components into a fully functional system. Let's talk about the sequence diagram. It starts with the user inputting lines to the user interface, which takes those input lines to the input component, which will create a line storage with the input lines that were given it. And when a circular shifter asks for a character from that line, it'll give it the character. And when an alphabetizer asks for a character from the circular shifter, it'll pass that down to the line storage, and that character will be passed all the way back up to the alphabetizer. And when the output asks for a character, it'll be passed over to the alphabetizer, then to the circular shifter, then to the line storage, which will find the character and pass it all the way back up to the output, which is how it'll create its output lines to pass up to the user interface and then to the user. Looking at the component diagram, the initial requirement is an input string. That's processed by the input component, which will set characters in the line storage component. And then to access those characters, the circular shifter will use a getCharacter method, and the alphabetizer will use a getCharacter for circular shifter, and the output will use getCharacter for the alphabetizer, where it will create the alphabetical shifts and pass it over as the final output. Looking at the class diagram, first of all, the line storage, circular shifter, and alphabetizer components will implement an iLineSet interface. A line storage will be made of multiple lines, and a line will be made of multiple words. The input will interact with line storage and master control, and then master control will interact with circular shifter, who will interact with line storage, and the master control will also interact with the alphabetizer, which will interact with circular shifter and line storage. Then that will interact with the output, which will create the output lines. A word is an array list of characters. The getCharacter method will return the character at the specified index. A line is an array list of words. The getCharacter method will return the jth character in the ith line. And line storage is an array list of lines. The getCharacter method will return the kth character in the jth word in the ith line with all of the specified indices. And that implements the iLineSet interface. This invokes the methods getCharacter, lineCount, which gives the number of lines in a line set, wordCountAt, which gives the number of words in the ith line, and CharacterCountAt, which gives the number of characters in the jth word in the ith line. Circular shifter is an iLineSet. It has an iLineSet reference that it'll get characters from whenever it invokes the getCharacter method. It has an array list of ints for line indices and an adjacent array list of offsets for where that circular shifted line would start. The makeshift method fills its lines and offsets arrays with lines from its reference that are not fillers, and it checks that with the isFiller method, which initializes a ref array of a long set of filler words. Then it'll grab a word from the specified indices that it gives it, turn it into a string, and find out whether or not that word is in this array. The getCharacter for circular shifter will first find what line in its reference it should look to, and then how far offset that line would be. If that line has to wrap around, it will, and then it'll call the getCharacter for that line index at that offset word at that character. The alphabetizer is an iLineSet. It stores an array of indices and also has a reference to an iLineSet that it would call whenever it invokes its getCharacter method. The sort method will fill in its array of indices from the reference that it has, and then it'll sort those using this insertion sort with the compare method that I used in the pipes and filters assignment. And its getCharacter method will call for getCharacter at a specified alphabetized index.
Hello, my name is Chad Marshall, and I'll be going over the rest of the classes. So here we have the input class, which creates the GUI that the user sees and that they are able to enter input into. And it also houses the button event handler, which controls the firing of the read method, as you can see here. So next, we have the button event handler. So what this does is it connects directly to the master control, makes a master control object, and then passes the entire input object through to master control. And then what this does, and before we do that, of course, we also read. Next, we go to master control. This is the heart of the program, and it also manages and controls the circular shifting and alphabetizing. And then we also have a display method here. Okay, so as you've seen in Steven's video, or part of the video, the circular shifter then takes whatever data that the user has. This would be the local reference that was passed to here. Now that gets sent to the circular shifter. The circular shifter then shifts it. And then we then pass that same object to the alphabetizer. The alphabetizer then alphabetizes it. And then we pass the alphabetizer object to the display, which then the display then outputs it to the window, which is the second window that you see on the user interface. Alright, let's go ahead and get started with the comparisons. So I've already done this once already, but I'll do it live as well. So here's the shifting first, then alphabetizing, and then here is the shared data result, and then here's the pipes and filters result. As you can see from the previous assignment in the pipes and filters result, the noise words are not taken out. That includes words that start with A, of, and all that. So let's go ahead and compare the times. So the time for this is 551 milliseconds. Eesh. And this one is 68 milliseconds. Our hypothesis, our theory rather, as to why this is increased is probably because whenever we create the objects as far as shifting and alphabetizing, instead of passing the exact same thing, which would be window.local, which we sent to circular shifter first, as you can see here, actually. Because we're sending this the new object at every single new operation, that's a form of copying the data. Now let's actually show a live version of this. So let's go to Eclipse and let's go to the data. Let's show the circular shifting first, or not the circular shifting, but the shared data first. So let's go ahead and run the test. Let's copy the data. First, let's make sure this is correct. Ooh, that is not correct. There we go. Okay, now we can run it. So let's run this. Yep, that's the correct one. And engage. Okay. So as you can see, this is about 619 milliseconds. And we can also clear it and run it again. We can also run it again. As you can see, there's no noise words, and it's been circular shifted first, then alphabetized. Next, let's go ahead and rerun this. Same thing again. 556 milliseconds, and then same result as you see. Now, let's go ahead and do the first assignment. So let's go ahead and run this. Now the largest difference between the two is that instead of running everything through the input, which manages the button event handler, we were able to centralize everything inside master control as far as an object-oriented approach. Now let's go ahead and do this. Here we go. So as you can see, it's circular shifted first and then alphabetized, and then as you can see, it has all the noise words. All right, let's go on to the next. So if we alphabetize first, then shift, it's a little bit faster for both cases, for both the pipes and filters and the shared data. Okay, so as you can see, you have this beautiful striping going on with the words because it's circular shifted at the very last. And it's still partially alphabetized, even though it's quite trivial at this point. Okay, so same thing as before. We believe that this is much more taxing than this one because at each new object we're passing the previous object instead of just passing window.local and having window.local being modified. Okay, so let's go ahead and swap this out and test it. So let's bring back the data just in case, and Eclipse. Okay, so as you saw earlier, this is how we can just easily swap these two. And let's go ahead and start this. So let's do shared data first. Run as Java test. Okay, engage. Ah, here we go. Now, as you see, you have this beautiful striping from the circular shifting. Okay, so, and the time is about 496 milliseconds, which is much less than, not much less, but a little bit less than alphabetizing, shifting first, then alphabetizing. So let's do the same thing for this. We can change the lists. All right, and go ahead and start this. Let's run this. Use the same data as before. Ah, yes. Here we have this beautiful circular shifting pattern, striping. Okay, and this is 44 milliseconds, which also coincides similarly with this pipes and filters. All right. Okay, thanks so much for watching.
Now you might be thinking to yourself, wow, that is a lot of function calls just for one character. Do these guys really think that would be efficient? And to that I say, sorry, I forgot what I was going to say.